here we go. Everything is fine. Good morning, everyone. This is Ashank David. Welcome back to Coders Arcade. And first of all, I wanted to ask that my stream is okay. I am visible. My audio is visible. My audio is audible. Sorry. And I hope so that it is absolutely clear. Alright, so welcome back to Coders Arcade, guys. This is Ashank David, and in today's video, in today's live session, we are going to talk about continuation in DSA. This is going to be session number 19, and we are going to talk about the binary search tree, or in this case, BST. So in the last session yesterday, I have done binary trees. So if you have missed that concept or missed that class, that session is going to be recorded, and it will be in the playlist, in the same playlist that this video is going to get onto. And also don't forget to share this stream so that this stream can reach as many people as possible. Those who guys are learning DSA and they want to learn DSA, but they are looking for a good place and source, please share them, because I am teaching it all for free, and we are going to focus on to placements. So share this stream as much as possible. With your love and support only, we will be able to create more and more videos, and we are motivated to come live every day teaching you something new. So please do like, share and subscribe to our channel also, and let's get right into the topic. So guys, welcome back and very good morning everyone. So first of all, if you missed this live stream, go ahead and you can get it in the playlist. So let us revise quickly what we did in the last class so that we can continue in this class. So yesterday in the live session, I just finished with the BFS and DFS in normal regular binary trees, where I have used recursion and I have used queues. Yesterday I have also told you about a little bit of STL queues, where I have explained you what exactly is STL and how it is used and what exactly is this queue thing. So we have all discussed about it in a very proper, in a detailed way. So now we are going to continue from there, and today we are going to start with the binary search tree, BST. Yesterday what we did was just a binary tree, that was not a search tree. So the data was put up in the random locations, in the random places. So in that case what happened was that it was not following a proper rule. So in this live session, we are going to talk about binary search tree, or in this case BST, which tells us about that BST follows a particular rule. What is that rule? What is that rule? Let us talk about that. Before that, quickly see what we did yesterday, and so that you are able to understand in a much better way what exactly we have done and what all things are very necessary here to understand about this class, because whatever we have learned in the previous classes will of course be applied here, and everything will be set. So yesterday we have understood about how we can, as you can see here, how we can we have seen that how we can create a binary tree and how to code for its DFS and BFS. This was the code for BFS. It was the code for BFS, this one, where we have seen how to do this. This was a normal your binary tree session here, and with the help of STL queues also I have explained you how the queues are going to get used and the logic for how you will traverse in the BT or binary tree in this case. Later on I have written the code also with this case. We have understood about the DFS part also, which is depth first search, and breadth first search was already done. This is going to be our DFS, depth first search, and I have told you about how the depth first search is going to work in this case, and yep, so this is how it was working. Now in today's class we will go ahead and we will create a new session today, and in this new session we are going to talk about binary tree. Let me just change the background so that it is visible. I hope so now it is much more clearer, and yep, so this is fine. This is going to be a new whiteboard, a new new binary search tree concept. Let us start, guys. So here we are now with our new concept here, binary search tree, binary search tree. Binary search tree. So how does the concept of binary search tree works? Guys, this is one of the most important problems or concepts that you will come across in your regular placements. So it is very necessary for us to learn about this binary search tree in a proper way. If you have any doubts, please do tell me in the chat and I will be able to see your doubts. Right here there is one screen where I can actually see all your comments and chats, whatever it is. If you miss this session, you can just comment us in the comment section and I will be clearing all your doubt, or maybe we'll be covering that doubt in the next session. Well, after every session we will have a small doubt session and there you can clear your doubts. So this is one of the most important concepts, and 110% if you are going to go for a technical job interview, 110% this is guaranteed that in the placements this is going to get asked. You are studying for placements, 110% this is going to be asked. This is one of the backbones of data structures here that you will ever come across, and so it is our responsibility to learn about this concept in a very proper manner. So this binary search tree basically is also usually called as, in the short form, as BST. BST. Now a lot of people don't understand what is the difference between binary tree and binary search tree. So let me clearly explain you about how and when did it started from. So if you remember what exactly was binary tree was just a simple normal tree. So I'll just make it here. It was just a normal tree which was in a binary tree format, means number of nodes are not more than 2 in each and every node connected to each other, but the data was placed anywhere, whatever data, we don't care. It was like that in terms of binary tree. This is a binary tree. What is it? It is a binary tree. We have already studied about this before. This is a binary tree, this one. Okay, now here the data is placed anywhere. Basically it can be placed anywhere. It is up to you how you place the data and how you want to execute it. Depending upon that, you just do it. But here there was no rule actually till now of placing the data into such a tree like this. So it was just called a binary tree because it just follows the property of binary tree that a number of node, any node particularly in BASIC, any node cannot have more than 2 nodes as its child node. This was the basic rule of any binary tree till now. But now when we are calling it as binary tree, right now this is what? This is binary tree. Right now this is what? This is binary tree. But now here the rule was simple, that it was just following the concepts of number of nodes connected to each other are not more than 2 or minimum 0. But in this case, let us say now, rather than putting the data anywhere at any place, what we will do? Now we will put the data, for example we have 100 here in the root, and let's say I want to put a particular element or insert a particular element. Say for example I want to put or insert, in this case, 30. Camera is gone guys, 1 minute. Let me just click it out. Apologies guys, you already know it happens in the stream because I am alone and I am doing the job of management in terms of cameras also. So I only need to operate the camera. So apologies for that. It might happen 1 or 2 times in between of today's session, or I need to change the battery also because the battery backup is not as good as the previous camera. But yeah, let us continue here. So just don't bother that please, and yeah, let us continue. So here this was a binary tree, but now you think one thing, based upon your roots data. Let us say you want to enter 30. Now you start comparing 30 with 100. Is a 30 greater than or lesser than 100? Is a 30 greater than or lesser than 100? It is lesser than 100. So anything which is lesser than the root node is placed towards the left hand side of the tree. This is the left hand side and this is the right hand side. Okay. So anything which is lesser than the root node is actually placed on the left hand subtree of the root, and that is the rule here. So this is the left subtree and this is the right subtree, or right child you can say, or left child you can say. And now because 30 you want to enter, 30 is lesser than 100, so 30 will be put up here, right here, onto the next available position. Our next available position is right here in the second level. This is the first level, this is the second level, this is the third level, right? So in this case 30 went here. So, and if any number or element or data is greater than the root element, in that case it will be placed on the right. For example, you want to place, let's say 150. Now check 150 is greater than 100 or lesser than 100. Of course it is greater than 100, so it will be placed onto the right hand side, right here on the next available index or position. I hope so that this is very much clear about this. Got it, guys? Next up, whenever you are, so next level is fulfilled. Now let us say I want to enter a number 10. Now 10 is actually inserted in this way that 10 is first compared with the actual root, which is 100. Is 10 greater than 100 or lesser than 100? Of course 10 is lesser than 100, so it will go towards its left. But we encounter one more element on its left subchild, so that 10 will be compared with the current root. So the root privilege will be changed to its left child, and you can see that 30 will be compared with the 10. First 10 got compared with 100. Say suppose you want to enter 10 and 10 was first compared with 100. Later on you thought we will go to left, but left already contained an element, so that 10 will be also compared with this 30, and once it is compared with 30, accordingly the same rule applies. In terms of recursion we will use here, and the same rule will be applied. So if 10 is greater than 30 or 10 is lesser than 30, 10 is lesser than 30, so it will go again on the left hand side, and here we will place the 110 because this is the next available position that we have. So this is the property of BST or binary tree. In simple terms, binary search tree follows the property of binary tree, but also it contains one more rule extra, which tells us that any number or any data which is greater than the root is placed onto the right next most available index, while on the other hand the smaller number or the smaller data which is smaller than the root is placed onto the leftmost available next index. So this is how it works, and this story will go on in repetition in terms of recursion. And what will happen? This way slowly your binary search tree will get filled up. Alright guys, so in this case let us complete this binary search tree first and understand about how this is working. So let us say now you need to enter 40. Now 40 is smaller than 100, so it goes on to the left, but 40 is now again compared by 30, which in this case 40 is greater than 30, so in this case 40 will be placed here. Now guys, one more thing, now this is left right subchild, so this is 100 is the grandparent of this 40, so 40 cannot be greater than 100 in this case any time. Are you getting my point, guys? I hope so that this is really very much clear. Okay guys, so in this case 10 is going to be always on the left child, but on the right hand child this will not be as greater as its grandparent. 40 will be placed onto the left subtree. That means all the values here are going to be smaller than 100. Understood my point, guys? Now any value which is greater than 100 will always go on to the right hand side. So there is no doubt about it. I hope so that this is very much clear to all of you guys. Understood? So in this case, let us say I want to now input 120. Now 120 is of course greater than 100, so it will go on to the right hand side, but again you found 150. So you will compare 150 by 120. So now 150 comes up to be greater. So in this case 120 will go on to the left hand side of the 150, and in the next available index is this only. So 120 is placed here. Remember guys, this 120 cannot be smaller than 100 because it is going to on the right hand side, but it can be smaller than its parent, not its grandparent. I hope so that this is very much clear. I should not say grandparent because in this case it is just the root. So make sure that you keep it in mind that the rules are properly followed. Alright guys, let's say I want to implement 160. Now 160 is greater than 100 and it is even greater than 150. So on the right hand side it will go and it will get updated right here in the next available index. And this is how this works guys. I hope so this is very much clear to all of you. And this is how the binary search tree. So once you follow all these rules, now this is not a binary tree anymore. It is a binary tree, but now it's a special kind of binary tree. It is binary search tree now. Now if you ask, sir, where does this name came from? Who brought this name? Where did this name came from? So as you can see, there is the word called as search added into this concept, which tells us that something is getting implemented here. Can you guess what is getting implemented here guys? What is the speciality of binary search tree? Why we are trying to keep the elements into a particular order following a particular rule? Why? The answer is in its name only, because actually we are doing binary search. Yes guys, yes, we know that binary search tree, the most efficient operation that you can perform in a binary search tree is binary search itself. Yes, and hence the name came binary search tree. The motto of creating binary search tree was to reduce the time to access or do any operation into this kind of a tree. Because you see, in our previous tree, in the binary tree, it was taking n number of time. Because anything you want to search, you need to search in every single branch or in every single order or level order. You need to search that element into for. But in this case, it is just halved. What I mean to say is, let us say you had a normal binary tree and you wanted to search for a particular element. You don't know where it can be, so you traverse in the whole tree. And when you traverse in the whole tree, it takes you a lot of time. It takes you a lot of code to execute and understand. But when it is all about binary search tree, what happens is, if you want to search any element, let's say you want to search for this 120. If you want to search for 120, you know that 120 cannot be on the left hand side according to the rule of binary search tree, that all the elements which are greater than the root itself are placed onto the right hand side, and all the elements which are lesser than the root are placed always on the left hand side. So by this rule, you know that if you want to look for 120, never go to left hand side. So basically you are dividing the tree into parts, and my camera went off. Wait a second guys, it came back and here I am. So in this case, you know this, that in a binary search tree, the most important function that could be performed is binary search. You know this now. This is the speciality of this kind of a tree, binary search tree. Got my point guys? If you want to search for 120, you will just do a half. Why do you want to go to left? There is no point of going to the left, because 120, you know that it will not be found in the left hand side. So the time complexity reduces drastically by half of the n. You can say log n, but we are going to talk about time complexities in a later class, in a later time. I will explain you how the time complexity concept works and how to apply that. I hope so that this is really much clear. So if in terms of efficiency, if we see, binary search tree is more efficient and faster operations can be performed onto it because of this rule and the property, guys. So there you go. This is the logic of binary search tree. Always remember, any element or data which is smaller than the root, left hand side, and on the element which is greater than the root, always on the right hand side. Understood? This is there. That's all, guys. Let us move on, and I hope so that this logic is very much clear to all of you. Now the question is, the biggest question for today's class is, how the hell we implement it? How the hell we implement it? So let us implement it together, guys. All right. So I want to. What operations we will do? What operations will perform? In this binary search tree, what all operations we could perform? We could perform operations like insert. Now guys, one thing. In binary tree, we did not create any insert or delete or nothing, those kind of functions, because of course in the binary trees it was up to you how you were adding the elements. You remember, we were doing root of left and then create node, root of right then create a node from the previous session, right? So what was that actually? There, because there was no specific rule followed, you could insert any element anywhere. It was up to you how you would do it. I hope so that this is really very much clear to all of you. But in this case of binary search tree, you cannot just put an element by starting from root left, right, you cannot do it. Well, because of that reason only, you have to create a specific function insert where you will write the insert algorithm which will do the insertion automatically by checking that rule, guys, of left and right. The same logic will be applied to insert the elements using the insert function. So there will be one function called as insert. Hope so it is very much clear to all of you. Alright, guys, I hope so that this is really much clear. Okay, I guess something happened in the stream. Is the stream healthy? Is the stream okay? Yes, it seems like. 1 minute, guys. A small interruption in the stream. I thought the camera went off, but it is not off. Yeah, we are live. We are still live. Okay. Okay, I hope so. The stream looks fine. The stream looks good. Everything is absolutely fine. Right. Yep. Let us continue, guys. Let us continue. All right. So, first thing first, do insertion. Next thing, what we will do next? We will do search operation. We will perform a search operation. Of course, binary search tree. If it's the name says binary search tree, we need to search also. So don't forget the search operation. This is equivalent, important, very much important concept that you should know, because this is the speciality of this binary search tree, or in this case BST. Got it, guys? Apart from that, one more thing that we will do, and that is gonna be remove, or in this case whatever you would like to say, remove or delete function. It is up to you, however you would like to do or perform any type of operation. These are the major operations. At last, we will write the display functions. What is our display function, guys? Now, display in itself is not a function, but display has two functions. And what are those? BFS and DFS. Copy paste the same concept from binary tree to binary search tree. It peacefully works as you want it to work. So there is no issue in terms of traversal. It is also, this is also a tree, that was also a tree. And binary search tree or binary tree, doesn't matter, BFS breadth first search or DFS depth first search will work absolutely fine in both the cases for the same exact code. I hope so that this is really very much clear to all of you. Got it? Understood this, guys? So let us see the code one by one. I'll give you an idea. I'll give you the skeleton of the code, I'll give you the idea, and then we will watch the code. We'll see the code, how it works, okay? Right. So, what all things we are going to do today in the code? We can start by creating a class node. You already know why we need this, because we need to create node, and for that we need a blueprint. That blueprint is going to be our node class. Very good. Okay. Next thing, we will create a class called as BST. Now guys, if you carefully observe here one thing here, in the last session when we were implementing the code for binary trees, we did not implement this class here or class binary tree, because there was no necessity of that particular thing. It was not actually required, or it was not necessary for us to implement a class called as binary tree, because there we knew this that we can place the elements according to ourselves. So there was no algorithm like insert or remove or search there at that time. So there was not a particular class for keeping or housing those functions. We directly did the job. So we did not require the use of classes and objects to implement a binary tree, but some part of it was actually necessary. But in this case, we had to create this to make sure to keep a track of all the functions, to keep a track of the logic, everything in one place. And for that reason, we need the class BST, binary search tree, where we will create the constructor, we will create the root node, right? We will create the functions, all of them. We will create it right here. Alright guys, let me press the button here, otherwise the camera will go off again and we need to reset it. So yeah, be careful about the camera now, the camera will not go off. Now let us continue, guys. So there will be a BST class. Now guys, I wanted to tell you about something very important, and that is, this code can be very much complex at first to understand, and it is a very lengthy concept, lengthy code also. But don't worry, to understand this concept, we will divide this program into two parts, this class into two parts, and that is private section of the class and public section of the class. What I am trying to say is that in the private section of the class, maintaining the abstraction level, we will write the actual logics with the help of helper functions. On the other hand, we will have a public section where we will actually write all the functions which are directly callable from the main function. I hope so that this is really very much clear to all of you, right? Yes. So let us see. So here one will be private section of the class, another will be public section of the class. In the private section and the public section, what we are going to write? In the private section, we are going to write the actual logic with the help of helper functions. Got my point, guys? And in the public section of the class, we won't require the helper functions. We will write the functions which are directly callable or executable from the main function. Are we getting this, guys? Are we getting this, guys? We have divided it into two parts. Guys, listen to this very carefully. This is the private section which will be hidden or abstracted. Now, which is following the concept of abstraction. Of course, if you don't know what is abstraction, go ahead and watch my C++ object oriented, mastering object oriented in C++ series. I've already created it and it is there in the playlist. One of the playlists is there. I'll give the link in the description below. I'll update the description. I'll give the link in the description below for that. It is a 5.5 hour course. If you do that, you will master object oriented programming in C++ for DSA as a prerequisite. For this only I have created that separate playlist. I have explained to you about all the things from object oriented programming, starting from what are classes, what are objects, what are the 4 pillars here: inheritance, encapsulation, abstraction, polymorphism. Everything is there. Constructors, destructors, specialized functions, getters and setters, everything is there which we are using here. Access specifies like what is private and public, everything is covered there. Because I don't have time to explain everything here in one class, I want to finish this DSA part. I have created another session there where you can watch and you can master object oriented programming in C++. So the concept is that we are going to create the actual logic functions which are going to create the actual logic with the helper function. Now in C++, helper function is, there is no such concept to be officially present in the C++ environment for helper functions. There are no such concepts called as helper functions. We are creating it for our leisure. That is why we are saying it is a helper function. Officially this concept doesn't exist, but I wanted to emphasize on this more because this is gonna help you to segregate your code properly and turn down the complexity of the code from very high to very low, where the code will also be lengthy and the code will also be enjoyable, code will also be visible and it will be understandable, but your code will be lengthy, but it will be also manageable to understand and write the code like that again and again with the help of helper function. So this is efficient programming. It will increase your efficiency. So that is the reason why I am talking about this helper functions. Helper functions are those functions where the actual logic will be written, but the callable functions are just the smaller function which are directly executable from the main. You will get to know what I am trying to say here very soon. Okay guys. So our class BST will be divided into two parts, and one is private part and another is the public part. So these are the two access level specifiers specifying the access of the particular functions here, and we are gonna talk about it. Let us move ahead into the code and understand the concept of BST. Alright guys, let us start. So here we have, I'll zoom in a little bit so that it is very much clear. Yeah. So here as usual guys, I have created I've used IO stream here. I have used the IO stream here guys. Okay, I have used the IO stream. I have implemented the queue. Why? Because I'm doing BFS and we know this, that for BFS we require the QSTL. Okay, so for that reason. Next up, I have using namespace std. You already know what is this. Then we have started creating the class node, where the node class is exactly the same as the tree which we were doing, where we have taken the what is the difference here now guys? I have taken up the key rather than the data so that it is much more clearer to understand. This is left and this is right. Okay, and this is the constructor. As I told you again, if you don't understand constructor, go ahead and watch my mastering C++ object oriented course, that is 5.5 hours course. It is already there in the playlist. You can find that and we will post the link also in the description below. Now we have created the binary search tree. As we have discussed that we will be creating another class here called as binary search tree. Okay, so we have done that. Now in the private section, I told you that there will be two sections in the class. Private section for private access specifier for private level access. We will have private section and we will have a public section of the class where these things which I have written here are all directly callable by the main function. So the main function here is going to actually use the public section of the class and where all the small mini functions. There is no again such concept of mini functions called as mini functions. I am just telling to explain about it. Okay, mini functions I am saying, but those are the just callable smaller functions which will be used for calling the operations. Got it, guys? So we have in the public section, we have the constructor of the class BST, and actually what we have done is we have initialized the root in the private section, maintaining the abstraction level of the class so that nobody can directly access the root in this case. Okay. So in the private section I have just declared the root, but right now it is a wild pointer. So to initialize it, we will use the null pointer, and you guys, you see I said BST constructor in the public section of the class, and here this is the constructor which is right now initializing the root to null pointer, to null PTR. I hope so that this is really very much clear to all of you, right? This is the constructor. Next, you see in the public section we have created a functions like void insert, bool search, void remove. These are the small or mini functions. Those are actually executable directly from the main function is actually calling it. And we have also done in order traversal, or you can say DFS traversal in this case, and BFS traversal both. So these are the small functions. So BFS traversal function is actually calling the BFS helper function, and the DFS traversal function is actually calling the TFS traversal helper function. So for each and every public function which is a smaller function or the mini version of it has its own helper function which are actually doing the job in the private section. So see, these are the codes which we have written in the private section. Now if you do it like this, the efficiency of the code becomes very high, and the simplicity of the code also becomes very easy. It becomes very easy for us to understand the concepts, and for that reason we are dividing the code like this into two parts, that is private and public. Now we might not able to finish the whole concept in just one class, but I'll try my best to finish this as much as possible. Let us start. So you see that for each and every function we have its helper function. So for example, in the smaller insert function like this, you only see here that for the, you see it's too much, void insert, see what all functions we have: insert, camera, we are back, we are back. Okay, so you see guys that for all the see all the functions which are kept in the public: insert, search, remove, traversal, insert, search, remove, traversal, both the traversal in order and pre-order, post-order, right? BFS and DFS both are there. Now in the private section we have insert recursively for the insert as a helper function. Okay, because of course recursion is applied as I told you, right? See, once the node is inserted, it has to be compared with the original root, and then again and again it needs keep on going and doing and checking the next root like that, right? So it is very important for us to use recursion here, because recursion is the way to crack this, guys. Okay, so the functions name are insert recursively, then we have search recursively, okay, so search rec, and in order recursively. Now up to you, in order, pre-order, post-order, whatever you want to do, you can just call it like this. We are doing in order, so roots key or data is being printed in the middle. We have already discussed about this in the previous session, and this is the BFS helper function. I hope so that this is really very much clear in your mind about what exactly we are talking about. Okay, let us start. So actually if you go down here, and if you actually go somewhere here, you see here our insert function. You see, this is a simple void insert function which is just accepting the key, which is written just after the construction in the constructor in the public section of this class. Void insert. Okay, void insert. in this insert it is using a key which is going to take up the value from the user as the data, and then it will actually make the changes into the root. You see, root is what? It is null pointer right now. That means there is no element in the root, means there is no binary search tree right now. So we need to do our first insertion, right? So as soon as the first insertion will be made, it will be set into that particular root node, right? So I said this root which is null right now will be getting it from the insert recursively function, where we have actually kept the logic in the private section of the class. I hope so that this is really very much clear to all of you. So I have called the insert recursively. Now insert function would require what? The insert function will require two things. One is the data which it needs to insert recursively, and the position of the root. Understood? What is the actual position of the root? Because you see that whenever you do the insertion, for example, you see here, let us say you are going to insert 100 first, and imagine the 100 is inserted. The first condition would be if the root is null, then in that root only you do the insertion. Understood? The logic could be very easy. The logic could be very easy. Let us see here. We'll draw a diagram and understand. Right now this is your root. Now root is empty. There is no element in the root. So right now when the root is only empty, do one thing. Whatever you want to insert, you insert it directly. Let's say 100 you wanted to insert, because the root was empty. 100 became the first root node itself. So we know this condition that if the root is equals to, we know this, that if the root is equals to null, equals to null. If root becomes null, then in that case only at the root allocate some memory using new keyword, call the constructor there and put up the key value, right? Can we do this? Can we do this? Root is already mentioned in the private section of the class, where it is just declared as node star root. Now we don't have to again use node star in this case, right? On that particular root only, which is null right now, allocate the memory and then calling the constructor, put the data. Can we do this? Yes, we can do this. So once your root is filled up with the key, you will now return that root. You will now return that root from the private section of the class to the public section of the class, where the actual root is getting called inside this insert rec, right? Insert recursively. So actually the call will come, this call will return the root directly to here, which will be set equals to root, which was actually null in the beginning. Are you getting my point, guys? Understanding this logic is very important. The whole game is in this logic only. If you understood this logic very well, this is a kid's play then later on. Understood my point? I know, I can understand that it will come from practice. In the very beginning, it may take some time for you to understand and analyze this. But once you get it, it becomes like a child's play. You got my point? Now because every day I am teaching this, most of the times I have taught this already. Because I am teaching it, for me, practice is like unlimited. I don't even know how many times I will teach this in my life. So I can just tell it without revising. I can just come here and I can just write the code like this. Because practice made me perfect. For you also, practice will make you perfect. So at the beginning, this might look a little bit complicated, but don't worry about it. Practice is the key. And don't worry, we are there to explain you each and everything and clear all your doubts. Hope so that this is really very much clear to all of you, whoever is watching at whatever time. Okay. So guys, you should only see that this is our root node, and in the root node, initially root was null, it was empty. So this condition got hit and at that particular route we allocated the memory and we put up the value, and then we returned that new route back to the call, and that was set into the actual route. Got it, guys? I hope so that this is really very much clear to all of you. Let me do one thing. We can divide this whole program into two parts. Okay. I will open it, split right. Okay. So I have, guys, divided the whole program into two parts and decremented the font size. I hope so that this font size is okay. Okay. On the right hand side here, or on the right hand side we have public section, on to the left hand side we have private section. Okay. I hope so that this is very much clear. And this font size is also okayish. This font size is also okayish. I'll zoom it in a little bit more. Okay. So there we go, guys. Here I'll explain you with the help of actual results. So that side we have public section and this side we have private section. Okay. We have done a little bit of partition here, and here, oh, my camera went off. 1 minute, guys. Oh, battery got. So as I told you, battery. I need to change the battery. Just give me 1 minute, guys. 30 seconds and I'll be there. 30 seconds, counting 30 seconds now. I need to replace the battery here quickly, guys. And battery is inserted. I hope so that you can hear me. As you can see, the battery is gone. You can also see that in there. Yeah, inserted a new battery and there we go. Okay, so I hope so that now it is visible to all of you guys. Alright, I hope so that this is visible. Correct. Apologies for that, guys, but what to do? I am alone here and I need to do it all on my own. Okay, guys. So in here I have divided the whole code into two parts. On the right hand side we have public section where you see I'll mark up the code so that you will understand it in a much better way, in an easier way. Where you see, guys, okay, now listen. That is public section and this is private section of the class. Okay. On the right hand side you have, on the left hand side you have the helper functions, on the right hand side you have the mini function, executable function, as I told you. The first function, void insert, this function we are talking about. What it is doing? Taking up the key. Okay, this is the data which needs to be inserted. Okay, guys, and what is the value of root right now? It is null. So root is null. Root is null, right? Our root is null right now. We are calling this insert rec function. This call went to this function. We called insert rec function, we passed the root which is null. So root is null right now. And we pass the key. Suppose key is 100, the first one. Suppose the key is 100. Imagine this. The key is 100. The root value, the key value, this key is 100. Root value is null. And when this is the case, root value which is null is passed here. So this is null. and the key value is 100 is passed. Root is null and key is 100 is passed into the insert rec. You see, what is the return type? Node star is the return type. This is actually returning node which got updated. You got this, guys? You got this, guys? Okay. So the call was made from here to here and this function started working. What is the value of root? The value of root is null. So does this condition meets? Yes. Yes, this condition is met. This condition is true, which means on that null root, allocate the memory, call the constructor and put that key which is 100. Okay. Okay, guys. Hope so that this is very much clear. So what happened is, say suppose this is the root. Say suppose this is the root. So right now this was null. So because root was null, we allocated the memory and put the data there only that time. Okay, guys. And this value, the new root is 100. What is the new root? It is 100. 100 is actually returned back to this insert rec call. This insert rec call, which is set to actual root. You got my point? Which is set to actual root. Root was null. So now null got updated to 100. Understood this, guys? First insertion is made. First job is done. Hope so. This is very much clear. Revise it again. First, let's revise it again. This is the private section. This is the public section. This is the function void insert. The key is 100. I called this insert rec function. Pass the root value was what? Null. So this was null. And what is the key value? It is 100. So it was called here insert rec. Root value is passed as null. And the key value is 100. Is the root null? Yes, the root is null. This condition is met. So allocate a new memory into the root and put the data or key, in this case 100, into it. Return that root. So that root is returned back, and where it is returned? It is returned directly to this call, which sets up the value into root. So the root gets updated to 100 as a new node. I hope so that this explanation is very clear and simple for you to understand. So guys, this function ultimately gets called in the main. And this is the private section where every helper function is kept. Got my point, guys? I hope so that this is very much clear. In the beginning it seems a little bit complicated, but it is actually not. It is very simple if you jot it down like this. Alright guys, this is the logic for the first insertion. Yet the first insertion is done. But we need to do what? We need to do multiple insertions, right? That too recursively. So we need to scroll down a little bit. Okay. Let us scroll down a little bit. So guys, now you see here. I'll take a screenshot again and I'll start marking up the code so that it is much more visible. Acha, you understood about how, guys, So you guys understood about how the first insertion was made. It was simple. Again, the root was null. So this was null and this was 100. So the null value came right in the root and the key value was 100, and this condition was met. So new allocated was done and this 100 was placed and it returned that 100 back to this, and the root value updates to 100. This is very clear. Now our first insertion is over. Now we have a second insertion. Correct. In the second insertion, the root value will not be null. Are you getting my point? In the first insertion, the root, this value was getting executed very nicely. You can see. Got my point? Understood? But in the case of second, where the root is already set to null, root is already set to 100, root is not null now. Am I correct? In this case, what will happen? Well, in this case, again the function gets called with a newer value. Let's say you now want to insert 50. Now you want to insert 50. The key value is 50. What is the root value? Root value is taken as updated 100. 100 now, and key value is 50. So now you see what happens here. Root is 100 while key is 50. The function is called again. The new root comes up to 100 and the new key value comes up to 50. Is root null? No. So don't do this. As of for now, don't do this. But come directly here. What is the key? Key is 50. Is it lesser than root key? Root key is 100. Root key is 100. Yes, this condition is met. If this condition is met, then do what? Go to roots left. That means, oh guys, camera again. Then go to root left. So if this is 100, then go to its left and then call the same function again. Call the same function again, but this time pass the root value as root of left. Root of left. Root of left is what? Null. So root is passed as null in the second insertion, in the second recursive call, and the key value is again 50, right? Green part is the second insertion, second recursive call. Okay, and now the new root key value is 50 and a null is being passed. We went to left and we passed this null. Understood my point? We went to its left and we passed this null. You got my point? In that case, the same function gets again here. This time the root is null. Yes, the root is null, this condition hits. And at this particular point, allocate the memory and insert the key 50. So 100 comes onto the left hand side of the tree, of the root, and it gets the memory allocated and it is inserted. Hope so. This is absolutely clear to all of you. If you have any doubts, please let me know in the chat below. But no chats yet, that means no doubts. Maybe you might not watch the session in the live currently, but later on if you have any doubts, please do let me know. Let us keep this session till here only, till this much only. Time is over, and I hope so that you have understood the BST concept, the binary search tree concept, as well as you understood the binary search tree concept, as well as the insertion, the private section, the public section, the helper functions, the executable, callable many functions. Already I have explained you all that. If you have any doubts, please do let me know. Well, that is there from my side, guys. I know this can be a little bit complicated to understand about BST, but don't worry, I'm still there. I'll be helping you. I'll help you in all the way possible to explain you this as much as possible. And yeah, that's cool. This topic might be covered in 2 more days, 2 more sessions. This topic will be over because this is a little bit lengthy. But ultimately, my job is to make this as easy as possible. Okay, guys? Well, that's it for this session, guys. I hope so that this is very, very much clear. Let's revise quickly what we did today. We started ultimately with our binary search tree concept, BST. We understood the difference between binary tree and binary search tree. Following the rules of left and right, we have understood. Any doubts here? What was the main operation in BST? Binary search. Because we know that if I want to find any value, we just divide it by 2 in the half. You got my point, guys? That is gonna be it. And these are the functions which you are gonna do. Right now we are doing the insert function. But later on, search and delete function we will also do, and later on display, that is BFS and DFS functions also we will be doing. Rest of all, I hope so that it is very, very, very much clear to all of you. This is the node class and the BST class, where we have divided our BST class into private and public section, where in the private we are using the actual logic or helper functions in this case, or in the public section we are directly callable, writing the directly callable functions which are written by the main, directly callable by the main from the main. Okay. We have understood the logic. If I wanted to do any insertion into it, then this will happen. This is the code which we were trying to understand. That is the public section of the class. This is the private section of the class. And I hope so that this is very, very much clear to all of you. 2-3 iterations we have done. In the next class, we will do more iterations and we'll understand about how this is going to work. I hope so that this is very, very much clear to all of you. Okay, guys. Alright, that's it, guys, for this session. If you have any doubts, please do let me know, guys, in the chats. There are no chats, that means no doubts, but later on if you see this, recording of this session will be kept into a playlist here. You already know the playlist. I'll give the link of all the notes and the study material for this lecture in the description below. It will be updated as soon as this live session goes off. And the next class that we will continue will on Monday. Tomorrow is Sunday, so on Monday we will be continuing this class again. For the timings for Monday, this class will be conducted at what time? Conducted at, I need to go to college, so I will be conducting the class at 7 o'clock in the evening, guys. Okay, just for Monday. From Tuesday onwards, we can either come into the morning or evening as your requirement. Okay, guys, I have given the link of the Telegram channel below and our Instagram channel also, so please go ahead and subscribe to our Telegram. Get connected to our Telegram, guys, because that is the place where I'll be keep on posting all the updates related to our notes, our videos, our concepts. You can have a discussion with us there in the Telegram group. We will be there. In Telegram, my name is Ashang David. I am the admin of the group, and there was one more sir there, Saurav sir, we two are the admin there, and we are always there ready to help. I hope so that this is really, really much clear. On our Telegram group, you can directly chat with me on our Telegram discussion group, where we can decide, and whatever you want we can decide in that particular thing. If there is any specific doubt, you can post it on that, and I'll create a dedicated video onto it and I'll help you out with that, guys. Well, apart from that, that's all for this session, guys. If you have watched this session till the end, I thank you so much, guys. And with your love and support, it motivates us to keep on coming live every day, to teach you something new, to teach you something good. It helps us, motivate us to keep on creating contents like this. So please do like, share and subscribe to our channel Coders Arcade, and don't forget to press the bell icon, and also share this stream to as many people as possible so that they can also learn DSA all for free. This is Ashank David, guys. Thank you for watching, and I'll be ending up the live stream. Next live stream on Monday, 7 o'clock in the evening. Don't forget the time. I'll schedule the stream before only, and you will get to know it very soon. Alright, guys. Every link and all the requirements, the study material of this particular lecture which we have done of BST will be provided into the description as soon as this live gets over. Well, that's it, guys. Thank you so much. This is Ashank David signing off. I'll see you guys in the next week. Till then, stay safe, happy weekend, and I'll see you in the next session. Thank you so much.